Hey grade 10s and welcome to this video. Okay, so this is the first grade 10 exam that I am working on. So welcome grade 10s and I hope you guys enjoy this video. Okay, so this video is from KZN and it is the grade 10 mathematics paper 1 and this is for June 2024. The marks allocated to this paper are 50 marks and the time allocated is 1 hour. Okay, so we have the instructions as usual. Make sure that you show all calculations and round off to 2 decimal places unless stated otherwise. Okay, so you guys can use this as a practice paper for your June exam this year, 2025, or any other year really. Okay, so let's get into this paper. Question 1, we are told to simplify fully, and this is what we have been given. So you're given two expressions that are being multiplied by each other. One is a binomial, the other is a trinomial. So here we have to use the foiling method. Okay, so we're going to take the first term and multiply it with the first term. This is equal to 6, and then x times x squared is x to the power of 3. And then first term times second term, and that's going to give you negative 12x squared because it's x times x. Then we have 3x multiplied by positive 1, which just gives you a positive 3x. Then we're going to multiply the negative 2 with every other term here. So the idea is just make sure that everything multiplies with everything. Negative 2 times 2x gives you negative 4x squared. Okay, that has a squared. And then negative 2 times negative 4 gives you positive 8x. And then negative 2 times positive 1 would give you a negative 2. Okay, and then we just have to simplify this. So put your like terms together. We have 6x cubed. And then these are like terms, so they go together. Negative 12 minus 4 gives you negative 16, and there's still x squared. Then we have positive 3 plus 8, which gives you 11, so positive 11x. And then just the minus 2 is the only constant, so that's what's left. Okay, so that is our answer. Moving on to the next question. Question 1.1.2, we are given an exponential expression and we have to simplify this as far as possible. Okay, so grade 10s, when you see expressions like this, you see the only way that you can simplify them, because all of them have just different exponents, okay? The only way you can simplify them is by using something called prime bases. So you're going to look at the base of each of these numbers and you're going to think about the kind of factors that they have. For example, 4, right? The numbers that can go into 4, of course, be like 1 and 2 and 4, but you're going to specifically focus on the factors of 4 that are prime numbers. So here you can see 1 is not a prime number because 1 has only one factor. A prime number has to have only two factors, 1 and itself. So 1's not a prime number. And 4 is not a prime number either because it has 1, 2, and 4. So 2 is the prime number. How can we express 4 to the power of x as a base of 2? You can express that by saying 2 to the power of 2. But you still have that x there, so it's still multiplying, so you can just leave it there. Okay, you could have decided to say times x, but it's really unnecessary. You can just say x. Okay, and then you have the 8. So what do we do with this 8 now? How do we express that so that its base is a prime number or is its prime factor? So with 8, it would also be, think about the prime numbers that can go into 8. Okay, that will be factors. That would be 2 as well. So it's going to be multiplied by 2, but 2 to the power of what gives you 8? That's 2 to the power of 3. Now, here's the thing. With 8, you see that the exponent has 2 terms. So because this is 8, what happens is that exponent is going to be outside of these brackets. And then it's going to multiply with that exponent of 3. Okay, so you still have there x plus 1 all over. And then we have 32. 32 also has a prime factor, okay? Now, there are easier ways of finding this, but you guys are grade 10s, so I would say try to not rely too much on the calculator because it's really going to build your skills in maths. So let's look at this. This is a way that you can quickly do this. On the side of the page, you take 32 and you're going to start dividing 32 by the smallest prime factor. Okay, so the smallest prime factor that you can think of 32 would be 2, because 2 is a factor of 32 and it's also a prime number. So if you divide 32 by 2, you get 16. So this is kind of how to do it. It's like the tree method. You divide it by 2, it gives you 16. Then 16 can be divided by which prime factor? 2 again. So divide it by 2 and you get 8. Again, 8 can be divided by 2 and you get 4. 4 can be divided by 2 and you get 2. And 2 can be divided by 2 and you get 1. And these, right? That's going to be what our base should be. So it's 2 times 2 times 2 times 2. 5 times basically. So 2 to the power of 5 is what gives you 32. Try not to rely on the calculator. It will really help you. In the exams, of course, you can double check with your calculator. Okay, so that's 2 to the power of 5. And then we still have the x plus 1 outside. So it's multiplied by x plus 1. Okay, so in the next line, all we're going to do is just distribute where necessary. So we still have 2 to the power of 2x. And then how we're going to distribute these? Do you see that these are on the exponent? So exponents multiply with exponents. So they're going to FOIL out. So the 3 is going to multiply with the x. Remember, you still have a 2 as a base. And then 3 times x gives you 3x. And 3 times 1 gives you positive 3. Okay, and then we say this goes all over, and again we do the same thing there. It's 2 to the power of, that becomes 5x, and then plus 5. Okay, so these two are still multiplying on the numerator. We have to simplify that out first. So multiply your two numbers there. The bases are the same and you're multiplying, so we need to do what to the exponents? We need to add the exponents. So that is 2 to the power of, and we're saying 2x plus 3x gives you 5x, and then you still have a plus 3. And this goes all over. We have 2 to the power of 5x plus 5. And now you have to divide. So when you divide, those exponents, because the bases are the same, the exponents are going to subtract. So you're saying all of this minus all of that. So just remember that when these are subtracting, okay, because this has two terms, you need to protect it with brackets. And so what actually happens is this will distribute, and you have 5x plus 3 minus 5x minus 5. Okay, so this subtracts that. And so what would happen there is you'll be left with the 5x are gone, and 3 minus 5 gives you negative 2. So that's what you have, 2 to the power of negative 2. And then we have to simplify this, okay? So do you see here the exponent is negative? When the exponent is negative, you're going to take this base, of course, and the exponent, and you're going to move it from where it is. Now you have to find out where is it currently. Currently, this is actually on the numerator because every number naturally just has a denominator of 1, okay? Because this number divided by 1 stays exactly that, just like 100 divided by 1 stays 100, okay? So now that we see that the exponent is negative, meaning we need to move this whole thing to the denominator. And when you do that, what happens is you have now 2 to the power of positive 2. And then what stays on the numerator is not this 1. They do not switch places. It is whatever was in front of 2, which you can actually see as an invisible 1. So that's what stays on the numerator. And so if you simplify this, this just gives you 1 over 2 squared gives you 4. And that's our answer. Okay, moving on to the next question. The next question, 1.1.3, we have an expression that we need to simplify. Okay, so in this expression, you have this, but you need to focus on the fact that we are subtracting and then adding. When you subtract or add fractions, what is the one thing that must happen first? You need to ensure that all your denominators are the same. Okay, so that's the first goal. We need to make all the denominators the same. But here's the problem with this expression that we have right now. Do you see this? We have no idea what exactly that is. How would you make this look like that? So that gets tricky. Now, to make it look more simple, we are going to factorize that so that we can see exactly what that is. So we have x plus 7 all over. And this is a trinomial. So we're going to open two brackets. And what times what gives you x squared? That is x multiplied by x. And then what times what gives you negative 6? That can give you a negative 1 in the middle, because that's the coefficient you have there. So factors of negative 6, you can say 3 and 2. But you can see that the 6 was negative. So one of it had to be negative, one had to be positive. So which one should be negative so that you end up with a negative 1 in the middle? You need to make the 3 negative because it's a bigger factor. If it stays negative, when you say negative 3 plus 2, the answer gives you negative 1, okay? Because it's big enough to not allow this to make it positive at the end of the day. Okay, so that is negative 3 and positive 2. And now that we know that, we'll be able to make the denominators the same. So we have 3 over x minus 3 plus 2 over 2x plus 4. Okay, let's look at our denominators now. How can we make all of these the same? So right now, when you're looking at this, you will see that these two were close. We can actually make those look the same because this has an x minus 3 and so does that. So if you just multiply this one by x plus 2, there we go. We have exactly the same denominators. And then now we see how this is a problem. And the thing is, it's actually not a problem. It's just that we didn't factorize it. This was supposed to be factorized. So 2x plus 4 can be factorized. Using what type of factorization though? This would be using highest common factor. Do you see that there are two terms here? And between these two terms, the highest common factor is 2. So that's what we're supposed to do here. We're going to take out a highest common factor of 2 and we'll be left with, so what are you left with in the first term? What do you multiply to 2 to get back to 2x? You multiply that by x. And then what do you multiply to 2 to get back to 4? You multiply it by positive 2. Okay, so do you see now that the denominators can actually be made the same? These two, we know that they can if you just make that x plus 2, right? And now we see this one has an x plus 2. We can also make it the same. Okay, so let's just look at this now and see, is there anything else we need to do? Do you see that here on the numerator and the denominator, you have a 2. Those can simplify, okay? And we're allowed to divide now like that because we have brackets protecting this. So 2 can divide by 2. So we're going to have everything again, but here the 2 and 2 divide. 2 divided by 2 gives you 1. And that 1 stays on the numerator like every other number. If I say 5 divided by 5, it gives me 1. But this 1 as a fraction is 1 over 1. Same thing with, let's say, 20 divided by 2. This gives you 10. But as a fraction, this is still 10 over 1. That 10 stays on the numerator. So naturally, when numbers divide, they go to the numerator. So this is what we have. And you see how we can actually get to make all our denominators the same. Okay, so this is what the first one looks like. You can see that the second one just needs to be multiplied by x plus 2 to be exactly the same. And the third one needs to be multiplied by x minus 3 to be exactly the same. So that's what we're going to do. So the method that we're going to use here is called LCD. Okay, it's really just what we did here. So we first state what exactly the common denominator is going to be, what all the denominators will become, which is x minus 3 and x plus 2. That's what they'll become. And then you're going to look at each fraction and ask yourself, how do we get the denominator to look like this? What do we multiply it by? The first one, how do you get the denominator to look like this? It already looks like that. So because that one doesn't change, look at how we're going to write it. We're all going to write everything under a common denominator. So this is x minus 3, x plus 2. Okay, so that's what it looks like now. And the numerator stays exactly the same because we did nothing to it. Now, the second one, do you see that we would have to multiply this by x plus 2? So what's going on here is you're multiplying it by x plus 2 on the numerator and denominator. That's actually what we're doing. And the idea behind that is you're not changing the value of the fraction, you're simply changing the way it looks. It's like multiplying something by 1. 1 can be expressed as 100 over 100. In the same way, 1 can also be expressed as x plus 2 over x plus 2. And that's really what we're doing. We're multiplying these fractions by 1. Okay, so you see that the denominator would look the same. It means that when we look at the numerator, all we are supposed to do is multiply it by x plus 2. So our numerator now looks like this. Minus 3 multiplied by x plus 2. Now let's look at the last one. To get these denominators to be the same, you multiply by x minus 3 on the numerator and denominator. So now that they look like that, do you see the denominator is already this, which is this? So all we're going to do is multiply the numerator by x minus 3. Okay, so it's just 1 times x minus 3, which is still x minus 3. Doesn't change. Okay, so let's simplify the numerator now. We have x plus 7, and this is going to distribute. So you have minus 3x minus 6 plus x minus 3 all over this same denominator that we have. Okay, all we have to just do now is simplify that numerator. So this is equal to, put all your x's together. These two are going to give you 2x. 2x minus 3x gives you negative x. So we've got a negative x now. And then the numbers. So a good thing you can do is cancel when you're done. So you see that we are done with the x's. And we just have to deal with the numbers. If you say positive 7 minus 6, you get 1. Minus 3, you get negative 2. So that just gives us negative x minus 2 all over this. And we have x minus 3 times x plus 2. Are we done? Almost, but you see that the numerator and the denominator, they have something in common. You see how this looks a lot like that? It would look exactly the same if you took out a what from here. If you took out a negative 1 as a common factor. So that's what we're going to do. This is equal to negative 1 or negative, and then open a bracket and you have x plus 2 all over the denominator that we have. And like this, because this is being protected by brackets, it can cancel with whatever it is common with in the denominator. So these two would cancel and you're now left with negative 1, because that is actually a negative 1, over x minus 3. And that is our answer. Negative 1 over x minus 3. Moving on to the next question. The next question, 1.2 and 1.2.1 says factorize fully, and we have a quadratic expression. So this is that type of trinomial where you can't really just, open up two brackets and start factorizing. Well, you can. There are two methods, and I would actually like to show you, grade 10, these two methods that you can use. One specific method is on my channel, the cross method, and then the factor method, I never really made a video on that. I just did it in some questions in grade 12 papers here and there. So let's go ahead and explore these two methods. Okay, starting off with the factor method. With the factor method, what we're doing is we're rewriting this expression, right, as 5x squared, and then in place of negative 2x, we're going to write two numbers that add up to negative 2. I'll show you how we get these numbers. So of course, we still have the minus 3. And now how we get these two numbers is by multiplying this first term and that last term. You see, when you multiply that, you get negative 15. So now you're going to think about two numbers. It's going to be negative 15, but I need you to think about it as negative 15x, because this is in terms of x, okay? So when you're thinking about negative 15, can you think about two numbers that multiply and give you negative 15, but when they're added, they give you negative 2? So really, I'm asking you for factors of negative 15. That's the whole point. Find factors of negative 15. Okay, there's 1 and 15. which is clearly not going to happen. There is 3 and 5 because 2 is not a factor. So you see that this is more promising. That can give you a -2, definitely. So we're going to put 3 and 5. And of course, they're going to be in terms of x. But now, how should you write them? Remember that your number is -15. So one needs to be negative for this to work out. Which one should be negative for you to get a -2 in the middle? The 5 should be negative because it's the bigger factor, okay? It's going to help to make this not positive. So this is 3x minus 15 that we're going to have. Okay, now how you structure it here is important as well. Well, it will help you. You need to put them next to the number that they have a highest common factor with. So with the -3, what you'll put next to it is the 3x because that has a common factor of 3. Okay, and then with the -5, you're going to put that with the 5x squared, so minus 5x. Okay, and that was a positive 3. It's positive in the first place. So that's what we have now. And now we're going to use a familiar type of factorization that you know as grouping. So we're going to group these two together and these two together. And we're going to take our common factors from them. So what is the common factor between 5x squared and 5x? It is 5x. Open a bracket. What do we have left? What do we multiply to 5x to get back to 5x squared? You multiply this by x. What do you multiply to 5x to get back to -5x? You would just multiply this by -1. Okay, here, when we take out a common factor, what is our common factor? It's going to be +3. Open a bracket. What do you have left? What times 3 gives you 3x? That is x. And then what times 3 gives you -3? That is -1. Okay, and when you see that these are exactly the same, you know that you are on the right track. So now we are going to still take our common factors, but this time it's an entire bracket we're taking out of these two terms. So what is common in these two terms is x minus 1. Then we're going to open a bracket and write what is left. In the first term, if you take x minus 1 out as a common factor, what do you have left? You have 5x left. In the second term, when you take out x minus 1 out as a common factor, what do you have left? You just have +3. And there we go. We factorize that using the factor method. And then we come to the cross method. This is how the cross method works. So with the cross method, again, we're looking at factors. We're going to look at now just the factors of the first term. 5x squared. What times what gives you 5x squared? Well, 5 is a prime number, so this one is simple. It's 5x times x. And then what times what gives you 3? 3 is also a prime number, so it's 3 times 1. But how you place it is important. See, if I place it as 1 and 3, look at what's going to happen. So with this method, I found that it is easier to work with these without any signs yet, okay, than working with it with signs. Because if you work with it with signs, it's really going to be a trial and error method. You're going to be working on different things, adding different signs, and then that just complicates things and wastes a lot of time. So what we're going to do here instead is already start multiplying. So I know like this is not going to work out. I'm just trying to show you why it won't work out. It's called the cross method because we're going to multiply across. So we'll say the 5x times the 3, which gives you a 15x, and then x times 1, which gives you an x. When you stare at 15x and x, do you think they can ever give you this middle term of -2x? No. Okay, so that means there's something wrong with your factors. You don't erase your factors immediately. You just change the order of one set. So instead of writing this as 1 and 3, you can write it as 3 and 1. That's what we're going to do. So let's see what that gives us now. If you say x times 3, that gives you 3x, and 5x times 1 gives you 5x. Do you see that that can actually give you a -2 in the middle if you put the negative in the right place? So if you give the negatives to the 5, you see that that works out perfectly. Now here's how we figure out what we just did. So this is going to give you -2x, just like our middle term. Okay, so that works out. Now this is how we figure out what exactly these signs are going to be. You see that the negative is in front of the 5x. what did you multiply to get 5x? You multiplied 5x times 1. So give the negative to the 1. So 5x times negative 1 is what gives you negative 5x. And then this is positive. So you must have said x times positive 3 to give you positive 3x. And those are your factors. It is still 5x plus 3. So it's like this and like that. Okay, so the second factor is x minus 1, just like we have here. Okay, so you see how you can decide which method seems easier for you, and you can use that for factorizing any type of trinomials that looks like this in future. Okay, moving on to the next question. Okay, question 1.2.2, the last question for question 1. We have x cubed plus 1 over 125. Looking at the x cubed, you already know this is a type of factorization which has to do with cubes. But do you see that we have a plus sign? So this would be the sum of 2 cubes. How do we factorize that? So we first of all start with one bracket. And in this one bracket, we're going to look at each term here and find the cube root of it. So the cube root of x cubed is x. And what's the cube root of 1 over 125? Well, 5 times 5 times 5 is 125. So the cube root of this is 1 over 5. So we have 1 over 5. And then you just leave that positive. Whatever it is, it stays exactly the same. So that's your first little bracket you have. Then in the bigger bracket, this is what we're going to have. So in this bigger bracket, we're first going to look at the first term and square it. So that gives you x squared. Then take the last term and also square it. So this is focusing on the first bracket. That would give you 1 over 25. So to get that middle term, you're going to multiply the first and the second term as it is. So it's x times a 1 over 5, which you can actually say is x over 5, but you can also rewrite it as 1 over 5x. That's still fine. Okay, because numerator times numerator, denominator of 1 times denominator. But you can just leave it as 1 over 5x. And then whatever the sign was, because you see we said x times a positive 1 over 5, just change it to negative. So that's going to be minus 1 over 5x. And remember that was positive, so we should have already said that. And there we go. So that is factorized using the sum of 2 cubes. Okay, so that is it for question 1, and we move on to question 2. Question 2, our first question, is a solve for x question. So we are given x times x minus 1 is equal to 6. Great, and do you see that on the right hand side, we have this equation being equal to 6. It's not equal to 0. If it was equal to 0, we could have simply said what is here multiplied by what is here is equal to 0. So it must mean the first thing is either equal to 0 or the second thing is equal to 0. Those are the only two ways that two things can multiply and give you 0. But this is not 0, this is a 6. So this means that you need to distribute so that you can take the 6 over. The goal is to get this right hand side equal to 0. Okay, so let's go ahead and distribute. So you're going to distribute here. And so this is equal to x times x gives you x squared. X times negative 1 gives you negative x. And then this 6 is on the right hand side. Bring it over to the left and it will become negative 6, okay, is equal to 0. And now that you have this, you have a trinomial, just factorize it and solve. I don't know why I said equal to there. Okay, so we open up two brackets is equal to 0. And then we have what times what gives you x squared, that is x times x. What times what gives you negative 6? Well, think about it. Factors of negative 6 that eventually when added give you negative 1. So factors of negative 6, don't try 6 and 1, it's not going to work. You can try 3 and 2. So you see those can give you a negative 1. Clearly one of it has to be negative, so give the negative to the 3 so that it is not enough to make it positive. It will stay negative. So that's minus 3, positive 2. Okay, so What I was speaking about in the beginning is how we have something multiplied by another thing and it gives you 0. The only way this is possible for you to have something times another thing and it gives you 0 is if this is equal to 0. Because anything times 0 gives you 0. So what we're saying here is, for this to actually happen, x minus 3 must either be equal to 0, or we can have a situation where this x plus 2 is equal to 0. If either one of them are equal to 0, then the equation would eventually give us 0 when we multiply these factors. So now we can solve for x, and we have x is equal to, and you're going to take this negative 3 over and it becomes a positive 3. Or, and take that positive 2 over and now we have a negative 2. And those are our answers. X can either be equal to 3 or x is equal to negative 2. Moving on to the next question. In the next question, we have an exponential equation where we have to solve for x. Okay, so notice something about this exponential equation. What do you notice is common all through? It's not just necessarily the 3. It's specifically the 3 to the power of x. You see, 3 to the power of x. So the best thing to do here is to break this up, okay, because it has 3 to the power of x minus 1. Break that up so that we can understand this better. So that is 3 to the power of x plus 3 to the power of x, first of all, when you break that up. And then you have a minus 1. So how do we get that there? Well, you're going to say, think about how this came about. For you to have gotten 3 to the power of x minus 1, you must have had bases that were the same and they were multiplying. So you had 3 to the power of negative 1. Because if the bases are the same and you're multiplying, you need to add the exponents. So x plus negative 1 is x minus 1. Okay, so that's what we have is equal to 36. Okay, and now that we have done that, because we have something in common, you're going to take out a common factor. So 3 to the power of x is common in both terms. We take 3 to the power of x out. And in the first term, what are you left with when you take 3 to the power of x out? You're just left with 3 to the power of x. So what do you multiply here to get back to 3 to the power of x? You multiply it by 1. And then here, what do you multiply to 3 to the power of x to get back to that? You would multiply by positive 3 to the power of negative 1 is equal to 36. Okay, so we just have numbers here now. 3 to the power of x multiplied by 1 plus and 3 to the power of negative 1. How would you rewrite that as a fraction? That would be, remember, this is on the numerator right now. So you see that exponent is negative. So you need to pull this whole thing down to the denominator. And so now you have a 3 to the power of a positive 1, which you don't have to write because the 1 can just be invisible. And on the numerator, the invisible 1 in front of this 3 will stay, is equal to 36. And then you have 3 to the power of x, and these two are being added. When you have 1 plus a fraction, 1 can be expressed as 3 over 3. So it's 3 over 3 plus 1 over 3, which is 4 over 3. Okay, so we can just say this is 4 over 3 is equal to 36. And now, remember, we're trying to solve for x. What includes x is the 3 to the power of x. So we need to get rid of this so that this is on its own and it can help us to better solve for x. So this is being multiplied. The only way to remove this 4 over 3 is by dividing. Really, you could divide both sides by 4 over 3, or you could multiply both sides by 3 over 4. That's what will get rid of that, okay? But let's just focus on it like this. So 3 to the power of x is equal to, and what is 36 divided by 4 over 3? So 36 is a whole number, but you can put it over 1 because it's working with a fraction, and then you're dividing by 4 over 3, okay? Grade 10s, don't focus too much on the calculator, especially when practicing. Now you have 36 over 1, and when you're dividing by another fraction, you're going to use a method called tip and times. So you're going to tip the fraction here, this fraction, second one, 3 over 4. That's how we tip it. We swap the numerator and denominator, and then you change that to a multiplication sign. Okay, so now we are multiplying 36 over 1 by 3 over 4. How do we multiply that? Well, you can start by looking for common factors across. Okay, so you see with the 3 and 1, there's no use of taking out a common factor, but with 36 and 4, we can. So 36 has a 4 as a factor. If you say 36 divided by 4, that gives you 9, because 9 times 4 gives you 36. And 4 divided by 4 is 1. So what we actually have here is 3 to the power of x is equal to this 9 times this 3 gives you 27, and then you just have a 1 in the denominator, which you don't have to rewrite. Okay, you can put it of 1, but it's still the same thing. Okay, so all of that is gone. That's really what we have now. And now how do you solve for 3 to the power of x is equal to 27? So this is an exponential equation, and you just have to make the bases the same. If you can write 27 as a base of 3, then we'll see what exactly the exponent should be. So this is 3 to the power of x is equal to 3 to the power of what gives you 27? 3 to the power of 3. And so that means now that the bases are the same, of course, that means now that x is equal to 3. So x has to be equal to 3 for these to be equal. Okay, so that is our answer there. Moving on to the next question. The next question, 2.1.3, we have an inequality, or really two inequalities. That's actually what this is. And we have to solve for x. Now, you don't have to separate the inequalities and then solve, okay? You can just solve it like this. Here's why I say these are two inequalities. This is kind of like saying x is greater than 0 but less than 3. These are actually two inequalities. You could have written them separately, but they're better written as one, okay? So this is actually the inequality. Do you see, if you look at this individually, what is it saying? It's saying that x is bigger than 0, is greater than 0, or 0 is less than x. So you can write that as x is greater than 0. And then when you look at this side, what is that saying? That is saying x is less than 3, so, or x is less than 3. That's actually why I say it's two inequalities. Okay, so we can solve for this. We don't have to separate them really. When solving for these inequalities, you need to focus on where x is. X is over here. And now focus on what is disturbing you from solving for x. What is the first problem here? The first problem is actually not the 3. 3 is not yet a problem. It's with the x. It's kind of stuck with the x right now. The first problem is the -1. We need to remove that. The only way to remove this 1 is by adding 1 on both sides. But I don't really like to deal with things like that or say adding 1 on both sides. What I say is we're going to take the -1 over. We have two inequalities, so they go on both hand sides. So you still have a -2 here. But now this -1 comes over and becomes positive. So it's a positive 1. Still follow the inequality. Okay, we have a less than. Then we have x over 3. We can just rewrite it as x over 3 because we know the 1 is gone now, that -1. And then this is less than or equal to, and you still have this 1 here. But remember, this -1 comes over and becomes a positive 1. So this is what you have. You've got -1, okay, if you add, and you have an x over 3. So -1 is less than x over 3, but less than or equal to, and we have 2 over there. Okay, now what is the next problem? What is stopping you from solving for x? It would be the 3 on the denominator. So ask yourself, what is this 3 doing to the x? It is dividing. So the only way to get rid of it is to do the inverse of dividing by 3, which is to multiply by 3. That will remove that 3 there. But this is an inequality or double inequality. So what you do here, you must do on both sides. Okay, it's kind of like what you do on the one side, you must do on the other side. So here we're going to multiply by 3 and multiply by 3, and that's going to remove that 3 like that. Okay, it cancels it out. So you have 3 times -1, which is -3, And follow the inequality. Now that is just x on its own because it is removing the 3. Is less than or equal to, and 2 times 3 is 6. So this inequality says x is greater than negative 3 but less than or equal to 6. That is our answer. Okay, moving on to the next question. Question 2.2 says a shop sells bicycles and tricycles. Okay, so one has 2 wheels, one has 3 wheels. In total, there are 7 cycles. So cycles include both bicycles and tricycles, and 19 wheels. Okay, this is like that rabbit and chicken question. Okay, determine how many of each there are if a bicycle has 2 wheels and a tricycle has 3 wheels. Now, this is for 5 marks. Okay, with these types of questions, there is that way where you don't actually need any calculations and you can actually think about the logic of it. But this is for 5 marks, so they want you to show working. Okay, so here's how we can think about it. So let me draw a bicycle. So we've got bicycles and tricycles. We don't know how many bicycles or tricycles we have. However, we know they add up to 7. So we would also have a tricycle. I would just have to add an extra wheel here. So this would symbolize a tricycle. Okay. So when you add them up together, they should give you 7. Okay. So in total, we've got 7 of these. So here's what we can actually say about that. We can call the bicycles, let the bicycles be X, and let the tricycles be Y. Okay, so what that means is because they are total of, they tell us that in total there are 7 cycles. It means that if you add X and Y, you get a total of 7. Okay, so let's see the other information that they give us. They say that the wheels add up to be 19. So we've got 19 wheels. So how can we actually think about the wheels and make some sort of equation from this? Okay, so you can think about it like this. This is a single bicycle and this is a tricycle, right? You know that a bicycle has 2 wheels. So for that, we can call the total wheels that the bicycles will have 2 times X. Because if you had 3 bicycles, for example, to find out the total wheels, you'd say 2 times 3, since each bicycle has 2 wheels, so there'll be a total of 6 wheels. So we can call 2x the number of wheels that the bicycles will have. And then the number of wheels that the tricycles would have would be 3y. Okay, because each tricycle has 3 wheels. So if you had, let's say, 3 tricycles, then the total wheels you have on this tricycle would be 3 times y, 3 times 3, which is 9 wheels. Okay, so this would stand for the total wheels on a tricycle. And what did they tell us about the total wheels? They said the total wheels are 19. So if you add the total wheels in a bicycle and the total in a tricycle, they should give you 19. Do you see that we have 2 equations here? This and that. And therefore, this is a simultaneous equation question. So how do we solve for x given this simultaneous equation? So you can start with the simple one. This, you can just make x or y the subject. I'll go ahead and make x the subject, and this is equal to 7, and we'll take y over minus y. So we can go ahead and call this equation 3. It's not really necessary, but okay, we'll follow the order. So this is equation 1 that we have here. This is equation 2, and we have just formed equation 3. Okay, so to now solve, all we're going to do is substitute equation 3 into equation 2, the one that we didn't use at all. Okay, so this is 2x plus 3y equals 19. So now we substitute this in place of x. So that is 2 multiplied by 7 minus y plus 3y is equal to 19. And here we just solve for y. So distribute, that's going to give you 14 minus 2y and then plus 3y equals 19. So So take what you need to take over. When you add here 3y minus 2, or just subtract 3y minus 2y is y is equal to, and you still have 19 here. If you take the 14 over, it becomes negative. So y is just equal to 5. Okay, so we got the answer of y. We know how many tricycles there are. To find x, what do? You can go ahead and call this equation 4, and then substitute equation 4, the answer for y, into the answer for x to solve for x. Okay, so this is x is equal to 7 minus y, and just substitute. So x is equal to 7 minus 5, and therefore x is equal to 2. So this means that there are 2 bicycles and 5 tricycles in total, okay, for us to have this situation that they gave us. Okay, so there are 2 bicycles and 5 tricycles. And moving on to question 3. We are now on question 3, the functions section of this paper. And we only have functions really in June. I don't really have anything like probability, stuff like that. It will be in the November paper, so we'll see how that goes. Okay, question 3 says 3.1. Given f of x is equal to x minus 2, which is a straight line, and g of x is equal to 3 over x, which is a hyperbola, which are not drawn to scale. Okay, a and b are points of intersection of the graph. As you can see, a and b are where these graphs intersect. DF is perpendicular to the x-axis, so it forms 90 degrees there with the x-axis, with points E and F on the graphs of G and F respectively. Okay, so that's all we have here. And the first question is to determine the coordinates of C. Okay, so how do we find the coordinates of C? As you can see where C is the y-intercept of the graph of F. So if it's the y-intercept of the graph of f, how do you find it? To find a y-intercept, you make x equal to 0. So you take the graph of f of x is equal to, and f of x is equal to x minus 2, and you simply make x equal to 0. So this is f of 0 is equal to 0 minus 2, therefore f of 0 is equal to negative 2. And so C is 0 and negative 2. Moving on to the next question. The next question, 3.1.2, says we have to determine the coordinates of A and B. So just look for A and B, understand what exactly are those points, and we'll be able to find those coordinates. So A is over here and B is over here. What do you notice about these points? They are the points of intersection between the graphs of F and the graph of G. Okay, the graph of F and the graph of G. Those are where those points intersect. So because they intersect at those points, what do you expect will happen here? You expect that at this point, the x value of the graph of F would be exactly the same as the x value of the graph of G. That's what a point of intersection means. And the y value of the graph of F would also be exactly the same as the y value of the graph of G. At both points, okay, they share the same x and y value. So if they are exactly the same at that point, what it means is they're just equal. So look at what the equations say. It says f of x is equal to something and g of x is equal to that thing. Please remember that f of x stands for y. It's y is equal to 2x minus 2. If you graph that, it would give you the same graph that we have for f here. And here g of x also stands for y. So what we are saying is, because we see that the x and y values are exactly the same at those points of intersection, you are going to make these the same. Make y equal to y. Y in the graph of f equal to y in the graph of G. And that will solve where these graphs have the exact same x values and y values. So in a nutshell, we are going to make f of x equal to g of x. Let's go ahead and do that. So this is going to be, we know that that was x minus 2, and this one was just a 3 over x. Okay, we're making those equal, and now let's go ahead and solve for x. So to solve for x here, you don't have to start taking this over, putting the x together and the y's together, not necessary. Here's why, because you have an x on the denominator. So what you can already do is, this is a fraction, it should be compared with a fraction. So let's make this a fraction by putting it over 1. And then we're going to go ahead and cross multiply. So we'll multiply the numerator here with the denominator here. So we're really just saying x minus 2 multiplies with x. You have 2 terms multiplying with 1 term. The only way to write that is by saying x is going to multiply with x minus 2. Okay, that's x minus 2 times x is equal to, and then denominator times numerator, which is still just 3. 1 times 3 is 3. And solve for x here. So we just have, as you can see, this is going to become a trinomial. One hand side is not equal to 0. It needs to be equal to 0 like we saw in question 1. So let's distribute here and we will get x squared minus 2x. And then you can go ahead and take that positive 3 over to become negative 3. Okay, open up 2 brackets and we have is equal to 0. Then x times x gives you x squared. What times what gives you negative 3? It's 3 and 1 that gives you 3, but this is negative. So one of it should be negative for you to get a negative 2 in the middle and for you to, of course, multiply and get negative 3. So which one should be negative? That should be the 3. So, and then plus 1. This is going to be, because negative 3 plus 1 is negative 2. Okay, so now solve x. Something times something gives you 0. So it's either the first something, x minus 3 is equal to 0, or the second factor, not really something, factor is equal to 0. Okay, solve for x. X is equal to, you're taking the negative 3 over to give you a positive 3. And here x is equal to taking the positive 1 over to give you a negative 1. So x is equal to positive 3 or negative 1. But don't lose track of what's going on here. They want you to find or determine the coordinates of, well, a and b. I honestly just thought they just wanted the coordinates. They want the x coordinates. So that's all they want. X is equal to 3 or x is equal to negative 1. Okay, so that means that is all. There's nothing we have to do there. They didn't really say substitute it and get the y values. So no need for that. That is our answer. Moving on to the next question. The next question, 3.1.3, says you need to determine the length of EF if OD is 6 units. Let's go ahead and look at that. So they want you to find out what exactly this length is, E to F, if OD is 6 units. If this is 6 units, all it means is that you went from 0 and you went 6 units to the right to get to D. Making D, see that it's on the x-axis. D is now an x-intercept whose coordinates are 6 and 0. Okay, because it's 6 units to the right. So what this means here is that the x value is 6. And you see that you have a vertical line here. This line is perpendicular to the x-axis. What that means is all through here you have a 6. And that's really what I should focus on writing. This is a 6. Okay. What does that mean for this coordinate E? This coordinate E, remember, it has an x and a y coordinate. What is the x coordinate? The x coordinate will also be 6 as well because it's on the same vertical line as D, and D's x coordinate is 6. So that is also 6. 6 and something. Okay. And F, the x coordinate, since it also lies on the same vertical line, its x value is also 6 and its y value currently is unknown. So they want us to find EF. The only way to find out that length of EF is to find out what exactly is the y value of F and what exactly is the y value of E, so that when you say that number minus this number, you get the length of EF. So that's our next goal. We need to find out what these y values are. But great, we have their x values. So we can substitute their x values into the graphs they lie on to find their y values. So F lies on the graph of F. Surprisingly, okay? F lies on the graph of F, and so we'll substitute 6 into the graph of F to find out what exactly that y value is. So the graph of f, remember, was x minus 2. So we'll say f of x, we know, is equal to x minus 2. And we're substituting 6. So we're saying f of 6, 6 is the x value, is equal to 6 minus 2. And so this gives you 4. So we know what that is now. That is 4. So we'll put it down. We found this to be 4. The next thing we need to find is the y value of e. So do you see that e lies on the graph of g, on the hyperbola? So substitute that x value of 6 so that you can find its y value. So we currently know that the y value is 4. Okay, let's go ahead and find this e. Okay, so another thing we can also do is just conclude exactly what that point is. That is for getting your marks. So you know this is 6 and 4. And to find g, you know that g of x was equal to 3 over x. And you're going to substitute 6 into here so we can find out exactly what that is. So 3 over 6 gives you a half. Okay, that's g of 6. So that tells us the coordinates of e, 6 and a half. Okay, so you can also put that there. We know this is a half. Okay, so to find the length of EF, you see that if you just say what is the distance from 4 or a half to 4, you must just say 4 minus a half and you'll find EF. So we're going to just write that down and tell them EF is found by saying 4 minus a half. And you do not really need a calculator for that. 4 minus a half, you can separate 1 from that. So it's like 3 plus 1 minus a half. 1 minus a half will always give you a half. So this is 3 and a half, which is really just 3.5. Okay, that is our answer. 3.5. 3.5 as a fraction is 7 over 2. Okay, so that is it. And they're in units because they're not in centimeters or meters. That is our answer for EF, and we move on to the next question. The next question, 3.1.4, says the equation, we need to determine the equation of j if j of x is equal to g of x plus 2. Okay, just follow what they're saying. J of x is equal to g of x plus 2. Where you have g of x, simply add 2 to it. So we're going to write the equation of g of x, which was just 3 over x, and then you say plus 2. That's all. That's 2. And that's our answer. Okay, so that's a 1-mark question. Moving on to the next question. The next question, we have to determine the values of x for which f of x is greater or equal to g of x, where x is less than or equal to 0. Okay, so the main question is this. This is just within that region that we need to find this. So we'll look at the graph for this. Where is f of x greater than or equal to g of x? Okay, what it means for a graph to be greater than or equal to. Remember, they're still saying f of x and g of x. These stand for y. So they're saying where are the y values of f? For example, if this is f and this is g, they're just asking you, where are the y values of f above the y values of g? Where are they greater than the y values of g? So you see now that for the y values of f to be greater than the y values of g, you're only going to look for places where the graph of f is above the graph of g. Okay, so here, and you look at them as vertical lines. Here, as a vertical line, when you draw a vertical line down, so your ruler will be very helpful here. You use a vertical line to see at this x value. Do you see that this graph of f has a bigger y value than the graph of g? Okay, and at this x value, whatever this x value is, the graph of f has a bigger y value than the graph of g. But when we get to this point over here, do you see that they're exactly the same? And then when you go behind it, at this x value, whatever that is, the y value of g now is above the y value of f. Okay, so it wouldn't happen here, anywhere here. It would be after they are equal, then you see that the graph of f starts having greater y values than the graph of g. So look for places where the graph of f is above the graph of g. Okay, so let's look at our diagram. We don't really need these lines anymore. Maybe those numbers will be important. We'll see. Okay, so looking at the graph of f and the graph of g. This is the graph of f. That's your graph of g. You need to look for places where f is above g. But they did say within a specific region. Okay, now here's the region they spoke about. They say where x is less than or equal to 0. Let's find that on the Cartesian plane. Where is x less than or equal to 0? Okay, so we don't have to waste our time looking for things that we don't have to look for. X is less than or equal to 0, looking at x now. Okay, this is your x values. That's your x-axis. Where are your x values? Less than or equal to 0. They're equal to 0 here. That's where x is equal to 0. Where it's less than 0 is over here. Meaning you only have to look within this region. Forget this one. Okay, so let's go ahead and look here. Within this region, this is only where we can look. Where is the graph of f? We're still now looking for that specific question. Where is the graph of f of x greater than or equal to the graph of g of x? Okay, so again, you're going to use a vertical line, your ruler. And you're going to move your ruler around this page just to understand where this is. You see that over here, for example, at that point over here, this is the graph of g that we have. Do you see that for this particular x value, that the graph of g has a higher y value than the graph of f? The graph of f would extend down like that, okay? It will extend downwards still. And it's going to have, unfortunately, a lesser y value than the graph of g. That's not what we want. We want f to be greater than g. F needs to be above g. You keep moving your vertical line, your ruler, keep moving. See, g is still greater than f. G, again, its y value is still greater than the y value of f until you get to this point of intersection. And once you get to that point of intersection, you see that they are both equal. That is something we're looking for because they said greater than or equal to. So you see at this point, they are equal. So we would need to find out what exactly that is first. Now, do you see this is the point A? They told us to find the x values of A and B previously, and we found those. Now let's just look at what they were again. They were 3 and -1. So 3 and -1 are the values of A and B. Which one would be for A? Since A is on the negative part of the x-axis, it would be the -1. So we can put that down. We can tell them that this is -1. Okay, so we know where they are equal. They are equal at -1, but where is f greater than g? Do you see that when you start moving to the right with your ruler, that the graph of f, the straight line, now has y values that are bigger than the graph of g's y value. G has a y value all the way down here, and for that same x value, right, the graph of f has a bigger y value. And this would actually just need to be thinner. Let me just make this line thinner so we can see this better. If you keep moving to the right, the graph of f has a greater y value than the graph of g. If you keep moving to the right, still the same thing here until you get to the y-axis. Okay, because a special thing happens to the y-axis for this graph of g since it's a hyperbola. At this point, right, you have something called an asymptote. So that's why this was just 3 over x. Okay, and an asymptote really just happens when we have an undefined value. Here's why it happens, because at x is equal to 0, if you substitute 0 into this, what happens? You have an undefined value, 3 over 0. Anything over 0 is undefined. So at that point, we don't have a fixed value. Okay, so we have an asymptote there. And then once you move past the asymptote, to the right, look what starts happening. The graph of g is now above the graph of f, and that's not what we want. We want the graph of f to be above the graph of g. So it only happens between from here, right? And I'm going to copy that, and then here at this point of intersection at A. So it's only happening between there. So where x is greater than -1, okay, all these places here, this is where the graph of f is always going to be above the graph of g, all of these places. So this is where x is greater than -1 but less than 0. Okay, but you have to remember they say greater than or equal to 0. So at -1 it is equal. So this is how we say this. We say that x is greater than or equal to -1 but less than 0. Is not equal to 0, because if your graphs are ever equal to 0 at this point, then the graph of g will also be equal to 0. And you know that the graph of g should not be equal to 0 because there's an asymptote there. You're going to have an undefined value. So that's our answer. X needs to be greater than or equal to -1 but less than 0. Okay, you can also write this as an interval. So this would be set builder notation. You can also write it as interval notation. So that would be where x is an element of, and you know that you're going from -1 to 0. But here we have greater than or equal to 0. So you would use a square bracket because the value -1 is included in the solution. But for 0, you use a round bracket because the actual value of 0 is not included in the solution. That's why it's just less than 0, not equal to 0. Okay, so that's our answer. And we move on to the next question, which is 3.2. The next question, 3.2, says, sketch the graph of h of x is equal to ax squared plus q if it is given that. Okay, so they're already telling you ax squared plus q, so you can see that h is a parabola. Okay, then they say that the range of h is -4 to infinity. You can see that -4 is included, and a is not equal to 0 but a is greater than 0, and q is less than 0. And then they tell us that one root of h is positive and the other root is negative. Okay, so the best thing to do is just to put down a Cartesian plane so that we can start thinking of all the things that they are saying here and how this parabola is going to look. So when you have a parabola, it's either concave up or concave down. Okay, curved up or curved down. Smiley face or sad face. The first hint is that the range of h is -4 to positive infinity. Let's think about what that would look like. -4 is maybe somewhere here, right? To positive infinity. It goes from -4 all the way to positive infinity. How do you think this is concaved? Concave down or up? And try not to guess, try to think about it carefully. If it's going from -4 all the way to positive infinity, it means it's shooting up. If it's shooting upwards, it's concaved up. Okay, so we already know that it is concave up. So maybe it looks something like this for now. With the first guess, with the first hint, I mean, it looks something like this. Okay, then the second hint is a is greater than 0. We can see that now. A is greater than 0. It's concave up. Then q is less than 0. You know that q in grade 10, q still stands for your turning point and at the same time your y-intercept. But q is less than 0. So it means that that turning point, we're going to now push it down all the way to -4. Here's why. Because when they tell you that the range is -4 to positive infinity, that's actually telling you what the last point on this graph, the lowest point I mean, is going to be. For the lowest point to be -4, it has to be the turning point because there will be no point lower than this. There's no graph below this. So the lowest point is -4. And so that actually makes a lot of sense. Q is less than 0 because Q is actually -4. So really the range told you what Q was. And then they say one root of h is positive and one is negative. Your roots are your x-intercepts. As you can see, one x-intercept is negative and one x-intercept is positive. So that is what our graph looks like. This is our graph and you can label this h. We don't need any numbers really, just that -4. This is our x and our y axis, and that is it for that question. Moving on to the next question. The next question, we have 3.3 and we have been given g of x is, and you can see this is an exponential function. And the first question is that we need to write down the equation of the asymptote of g. Okay, so the asymptote of g. An exponential function only has one asymptote, okay? It either looks like that or like that. It can be below like that or like that, okay? Only has one asymptote, and the asymptote is that horizontal line that it will have, that the graph will not go below or will not go above. So right now, this is in the form of y equals a times b to the power of x plus q. Now, the part that tells you what that asymptote, that horizontal asymptote is the q. The horizontal asymptote is always y is equal to q. So in this case, you can see that our q value is negative 12. So the equation of our horizontal asymptote is y is equal to negative 12. And that is our answer. Moving on to the next question. The next question is determine the y-intercept of g. The way to find the y-intercept is simply by making x equal to 0. Because if a graph lies on the y-axis, at this point, this is where the x value is 0. Okay, so we're going to make x equal to 0 by saying g of 0 is equal to 3 multiplied by 2 to the power of, and you see x there, so you put 0 minus 2. And let's just simplify this. So g of 0 equals 3 multiplied by 2 to the power of 0 gives you what? Anything to the power of 0 is 1. So this is 3 minus 12. And 3 minus 12 is equal to negative 9. So negative 9. And so g of 0 is negative 9. Did they specifically say coordinates? No, they just said y-intercept. So you can leave it like that. That is your answer. Moving on to the next question. The next question, determine the x-intercept of g. Okay, if it's an x-intercept, then the y value is equal to 0, because if something is on the x-axis, its y value is 0, okay? So in this case, we're going to make y equal to 0. So if your equation is g of x is equal to 3 times 2 to the power of x minus 12, how do you make y equal to 0? What does y stand for? G of x, okay? If you replace this with y, it would mean the exact same thing. So it's 0 is equal to 3 times 2 to the power of x minus 12. And now you just have to solve for x. So right now you see that x is the exponent of this base of 2. So you need to leave 2 to the power of x on its own. In this expression, right, you can see that there are two terms because terms are always separated by plus or minus signs. We have a minus here, so this is the first term, and that's the second term. So what do you have to get rid of to get closer to that x? Right now the 3 is multiplied by the x, so it's kind of like together. You can't just separate them. So the first thing we can get rid of is the 12. It's negative, so why don't you take it over? So when you take it over, it becomes positive 12 is equal to 3 multiplied by 2 to the power of x. So now that 12 is gone from this hand side, what is the next problem? It is the 3. And what is the 3 doing to the 2 to the power of x? It is multiplying. So the only way to get rid of it is to divide. That's the inverse of multiplying. So we would divide, but this is an equation, so what you do on the one side, you must do on the other side. 12 divided by 3 is 4, and this is equal to, these would cancel, and you're left with 2 to the power of x. You can't just rewrite this as 2 to the power of x is equal to 4. Now that we have this, it's an exponential equation. In an exponential equation, you just need to make the bases the same so that we can equate the exponents. So 2 to the power of x is equal to 4 as a base of 2 is 2 to the power of 2. So therefore, this means that x is equal to 2. And there we go. So our x-intercept is x is equal to 2. It's really 2. Our x-intercept is 2. You don't really have to write this as a coordinate because they didn't ask for the coordinates. They just want you to determine the x-intercept. Okay, moving on to the last question for this paper. Okay, the last question, 3.3.4, says sketch the graph of G, clearly showing the asymptote and the intercepts with the axes. Okay, yeah, we should have known already because they started asking for things. So we have a Cartesian plane. You don't have to number your Cartesian plane, it's not necessary. So we have our x and our y axis, and let's go ahead and start plotting. So the first thing to put down when sketching an exponential function is your horizontal asymptote, okay, that horizontal line. And we found what that was. They told us to find it, and it was y equals -12. So we know it's on the bottom. So all you're going to do is you're going to draw a dotted line. Don't worry, I'll make my line dotted now. And that line is going to be called y equals -12. And now that we have done that, the next thing to do is we're going to consider the shape of this graph. Okay, so the graph was called g of x is equal to, and I think I should just put it here. So 3 times 2 to the power of x minus 12. We already got the minus 12 part down, but you need to think about the shape of it. And when I say the shape of it, I mean, is it above the asymptote? Is it below the asymptote? Is it increasing or decreasing? It's really those two things. Where is it in relation to the asymptote, and is it increasing or decreasing? Now, there's a whole textbook way to find this out. You have to think about what A and B are, and you have to memorize that table. But I would rather you don't do that and you actually work through this for understanding. So you don't have to memorize things, because when you just memorize things for memory's sake, you don't actually understand it. You've just crammed it over time. So here's how we can answer these two questions. Is it above the asymptote or below? The way we answer that is by looking at what is in front of your base. So your base is whatever carries the x. What is in front of our base is a 3. 3 is a positive number. If the number in front of the 3 is positive, your graph lies above the asymptote. So we already know it lies above the asymptote. We just need to find out, is it decreasing, meaning moving downwards? You always read graphs from the left going to the right. Or is it increasing, now that we know it's above the asymptote? Okay, easy way to find out whether it's increasing or decreasing is simply by substitution. Okay, grade 10s, take two numbers that go right after each other. So 1 and 2 is a very easy one. We're going to take 1 and 2, and you're going to substitute them in place of x. So when you substitute 1 into this, what does it give you? Feel free to use the calculator here, because it's really just to test whether it's increasing or decreasing. Do you see that when we substitute x as 1, we get a y value of -6? Okay, substitute 2. So change that to 2, and now you get 0. Here's what we can see from this. You're looking at what the y value is doing when you went from 1 to 2, because that's how you need to read graphs, from the left to the right, like you read words. If I went from -6 to 0, what did I do? Did I increase or decrease on a number line? We increased, because this is negative, and went to 0, which is moving towards positive numbers. 0 is not positive, it's neutral, but it increased. So now we know what this graph is doing. It is increasing. Remember, we read graphs from left to right. So which one is it? Is it this graph or this graph? It would be this graph, because it is increasing, moving upwards. This one is moving downwards. This one is moving upwards. Always think about it like a stick man. When he's moving to the left, okay, he has to move to the right actually. He needs to walk up this graph. Okay, so it's increasing. So now we know what our graph is doing. We also know what the x and y intercept are. It's not really too important, but we'll draw our graph. It is increasing. Well, increasing. And now we can put down the x and the y intercept. So the x-intercept we found was 2 when we substituted 0 in place of y. So that is the x-intercept of 2 over here. And the y-intercept, when you substituted 0 in place of x, was -9. So that is the y-intercept you can put over here as -9, and your graph is complete. Just make sure to label it. It was the graph of G, so label it G. And that is it for this paper, grade 10s. I hope you guys enjoyed this video. I will also be making a paper 2 of this paper. Hope to see you guys in the next video, and all the best for your exams. Bye.